Hi everyone, so we are going to be looking at the topic polymers. Now a polymer is a very large molecule, it's a very long molecule that is made up from small molecules that combine together. These small molecules are called monomers. So many monomers come together and they form a polymer. So they join together by covalent bonds. And the process by which a polymer is formed is called polymerization. So for example, you can have ethene. This is how ethene looks like. Ethene combines with itself many times to form polyethene. So ethene is the monomer and this is going to combine with itself several times. So you can have 50,000 ethene molecules that combine and forms polyethene. Now there's different examples of polymers. You have natural polymers, you have synthetic polymers. So examples of natural polymers are proteins. Proteins are made up of amino acids. So this is the monomer. So many amino acids combine together to form proteins. You have polyester. One example of a polyester is PET. You have nylon, which is also a polymer. Now, there's two types of polymerization reactions. There's addition polymerization and condensation polymerization. We're going to look at one of them at a time. Addition polymerization occurs when unsaturated monomers means they contain C double bonds. These monomers join together to form one large molecule as the only product. This is the important keywords here. It is the only product. So addition polymerization involves unsaturated monomers and it produces only one product. There's no other molecules or atoms lost during the process. And unsaturated monomers, these include alkenes. So all alkenes can undergo addition polymerization. So I'll take the example of ethene. So ethene looks like this. I'm going to draw it like this so that you can see the polymerization happening. So I have drawn 3 ethene molecules, but in real life you're going to have thousands of ethene molecules. So these 3 ethene molecules will join together to form polyethene. So polyethene is the same. So this is the ethene. The only thing that happens is that this double bond is going to split open and it forms a single bond everywhere. So you can see here I have one ethene. That's the one ethene here. It has joined with another ethene. That's the second ethene. It has joined with the third ethene. This is the third ethene. And so on. The molecule can keep on growing. So this is ethene and this is polyethene. Ethene is in brackets. So I have polyethene. And you can see that this I've left it long, showing that the molecule can keep on growing. So this is polyethene molecule and I have shown 3 of the monomers here. Polyethene can also be shown like this, where I am drawing only the monomer, the value of N, like this. N means that this part here, N means that this part here will keep on repeating itself innumerable number of times to give you polyethene. So what I'm just doing, I'm just opening up the double bond. It mentions here one of the double bonds in each CC double bond breaks and form a bond with the adjacent monomer. So this bond breaks, let me put it in purple. So this bond breaks and starts to form a bond with the adjacent carbon. And if you can recall, one bond is made up of 2 electrons. So if I'm looking only at this bond, so this is made up of 2 electrons. So when this splits, I have 1 electron here and I have 1 electron here. So this has split, 1 electron here, 1 electron here. Same thing happens here. This one is going to split open. I have 1 electron here and 1 electron here. Now these 2 electrons that you can see, 1 electron here, 1 electron here, these 2 electrons can come together. And when they come together, these electrons are shared, so you have the formation of a covalent bond here. So that's why you end up with a covalent bond here. So the double bond just breaks and then it forms a bond with the adjacent carbon. Like this. This will also open. These 2 electrons are shared. That's what is shown here. Now this electron is alone and this is going to bond to something else. That's why I'm having this bond here. So this is going to bond with something, but we cannot show 50,000 molecules of ethene. So we're just showing 3 of them. So this will bond with something else. This will bond with something else. So that's why I showed this as a continuation of the molecule. So when we're naming the polymer, it's poly and the name of the monomer in brackets. So for example, if you're using the monomer propene, then the polymer will be polypropene. If you're using butene, the polymer will be polybutene. So it's just the name of the monomer with the prefix poly. So if I have propene molecule, propene is going to have 3 carbons like this. Now for me to draw polypropene, it can get a little bit tricky because you can see the chain is like this. Okay, there's an additional CH3 here. So it's not as easy as this because here you had H everywhere. Here you have CH3 here. So then what I will do, whenever I have a polymer to draw, what I will do, I will try to convert the molecule in this format. Like the CC double bond surrounded by 1, 2, 3, 4. 1, 2, 3, 4 can be anything. Could be H, could be Cl, could be CH3, could be C2H5. So I just want to convert the molecule in this format so then I can just join them side by side. So this is my 2 carbons separated by the double bond. So this is my 2 carbons separated by the double bond. So I'm going to redraw this. So I have carbon, double bond, carbon. And then you can see that I have the H, and the H here. So an H here and an H here. So this will go here and here. And you will see that I have, on the second carbon, I have H and I have a CH3. So then I will draw H and I will draw CH3. So this will be my monomer. It's the same thing. It is still propene. It's the same thing because I made this molecule from this structure, but it is in this format. So then I can just bring this one after the other and I have my polymer. So if I draw 3 of this propene molecule in this format, like this, I can now combine these 3 to have my polypropene molecule. So I'm just going to line them up one after the other, but without the double bond, only a single bond, and then I will just connect all of them. So this is my first monomer. To this I'm connecting my second monomer. And to this I'm connecting the third monomer. And I have single bonds everywhere and I will extend the bond Now, in core, you are supposed to know the problems due to polymers, and you have to know that plastics are actually made from polymers and that plastics are non-biodegradable, which means that they do not decompose by bacteria in the soil, and this is why they take up space in landfills and it causes environmental issues. Now, waste polymers are dispersed in landfills. And because they just keep on accumulating and because they do not break down by bacteria, they take up land. And this is why landfills tend to fill up quite quickly, because the polymers, the waste polymers, are not broken down by bacteria. There's also another problem of ocean pollution, because plastic will also accumulate in the ocean. They disrupt marine life, so they can get entangled in fins. Aquatic animals can eat them, so it disrupts marine life. Now, yes, they take up space, so what we can do, we can burn them. So when we burn them, they break down. But the problem when we burn plastic is that it can produce dangerous gases. It can produce poisonous gases. For example, polyvinyl chloride, this is PVC. So this is also a polymer. It produces hydrogen chloride gas on burning. Hydrogen chloride gas is a very acidic gas which can be dangerous. So we try not to burn the plastics, so we try to reuse the plastic objects. But in some cases, if you're able to treat these acidic gases and if you're able to eliminate the problem of these waste gases, the burning of the plastic also produces a lot of heat. And this heat energy can be used to supply factories with power. So this is an advantage of burning the plastic, and this is a disadvantage of burning the plastic. Next, we're going to see how we can identify repeat units in addition polymers. So we've seen that addition polymers, these are two examples of addition polymers, where you can see that this spot here keeps on repeating itself. It's very easily identifiable. Here you can see that this spot repeats itself. The part that repeats itself is called the repeat unit, and we can write it in this case CH2, CH3, CH3. Here. This can be seen as the repeat unit. I'm just taking the part that repeats itself and just redrawing it. So I have CCl, H, like this. So I'm just redrawing the part that repeats itself. This is called the repeat unit. You should be able to identify repeat units. Now from the repeat unit, I can get the monomer. Remember that the monomer will have double bonds. So the repeat unit where you don't have, you just take the repeat unit and you just eliminate these additional bonds that are starting to form, and you just collapse back to get the double bond. This will give you the structure of the monomer. So I'm just going to redraw. So CH2, CH3 is the same thing, but I will collapse back the bond so that I have my monomer. So my monomer must be an alkene. Must be an alkene. It must be unsaturated. It must have C double bond C. So same thing here. I will repeat. I have the CH3, CH, H and H, but I will collapse back the bond and I form the double bond. This is the monomer. And if I look at the monomer, I can name it. So this one has 1, 2, 3 carbon. So an alkene with 3 carbon, this is called propene. Second one, this is an alkene with 2 carbons, so this is called ethene, but you also have a chlorine here, so this is called chloroethene. So these are the name of the monomers. Now for the next question, you're going to use these 2 monomers provided. You will name the monomer, draw the repeat unit that I'm writing as RU, and you will also draw the polymer. Pause the video, work it out, and then check your answers. So you can see here, this is chloroethene. This is the repeat unit. When you draw the repeat unit, you draw, it's just the monomer without the double bond, and the bonds open on both sides. You put the brackets and you put N. N means that this repeat unit is going to repeat itself for a large number of times. And from the repeat unit, I just take the repeat unit and repeat it 3 times. I'm going to have the polymer. So in this case, polychloroethene. So normally, if you repeat the repeat unit 3 times, this is just enough for you to show the polymer. And these bonds have to be shown going outwards. Similarly, here you have dichloroethene. If you want to be specific, you can put 1,2-dichloroethene, showing that the chlorine are on the 2 different carbons. So 1,2-dichloroethene, this is the repeat unit. It's the same thing here. I just put the bond straight, and I've broken the double bond, put it as single bonds, and showing N, including the brackets. And the same thing has been repeated 3 times to show the polymer and these bonds going outwards. So this is poly 1,2-dichloroethene. You will have to complete these questions and then you check your answers. So for this question, you can see that for this polymer, this is the part that is repeating here. In this case, the chlorine is on top. In this case, the chlorine is at the bottom. It doesn't make any difference because anyway, it's the same molecule. So this is C double bond, C, H, Cl, H, H. So if you look at the answers provided, it's going to be answer C. So these 2 cannot be the answer because there's no double bond. Here there's 2 Cl, but in the monomer there's only 1 Cl. Second question, you have to describe the polymer. The polymer is saturated. There's no double bonds in the polymer. The monomer is unsaturated, but the polymer is saturated. So it is a saturated compound. This is the monomer. This is ethene, so this is polyethene. So it's just the name of the monomer with poly in front. So it's polyethene, but it is saturated. It has no double bonds. Here, which shows formation of a polymer. You have the monomer. The monomer has to be an alkene. So it has to be ethene, and then the polymer will be polyethene. For this question, you just have to add, this is Br, not B, because you're just adding bromine. So this is an addition reaction. So bromoethene is going to add between the double bonds. So the double bonds open up and you get dibromoethene. For this one, you have to go back to addition reaction of alkenes. This is called bromination. So you have the 2 bromine that adds here. The formula for the polyalkene is given. You have to deduce the monomer. So it's very easy. You're just going to repeat the same thing exactly as it is here, but instead of having single bonds, you will have double bonds. So this is the monomer.